Question 1 asks us to differentiate a number of different functions. So we're basically just going to be finding a bunch of different derivatives. The first one asks us to differentiate the function h of r equals a over r to the b minus k e to the r. The key thing about this question is to notice that r here is your x. R here is your independent variable. So every other variable here is a constant. So the first thing I'm going to do is I'm going to rewrite this as a times r to the negative b minus k times e to the r. Then I can go about actually finding the derivative. What is h prime of r? Well, if I differentiate this one, I'm going to use the power rule. It's r to the negative b. So I bring down the negative b, I have negative a times b times r to the negative b minus 1. Now this one, I've got e to the r. So I'm going to use the e to the x rule. The derivative of e to the r is just give me e to the r. So I'm going to have k times e to the r here. This is going to be the derivative of that first function. For 1b, we want to differentiate this function here. Y equals 2 to the x times square root x squared minus 5. There's a couple different things going on here. We've got a square root of x squared minus 5. This thing here we're going to use the chain rule for. And I've got a 2 to the x multiplied by that. So I'm going to have to use a product rule. So first I'm going to write out the product rule. I'm going to take the derivative of the first times the second plus the derivative of the second times the first. Now when I'm taking the derivative of x squared minus 5, basically this is like x squared minus 5 to the 1/2. First I do the derivative as if the x squared minus 5 was just an x. So I'll get a half times x squared minus 5 to the negative 1/2. But then I have to multiply by the derivative of the inside function, by the derivative of x squared minus 5. Here the derivative of 2 to the x is 2 to the x ln 2. And I've got square root of x squared minus 5 here. Now I've got one more derivative I need to take, this derivative here. So the first part, 2 to the x ln 2 is going to stay. Square root x squared minus 5 is going to stay. Here we have this thing to negative 1/2 is the same as the square root of it on the bottom. X squared minus 5 prime is the derivative of this, which is 2x. Multiply that by 2 to the x. So I'm going to get a 2x times 2 to the x on the top. And the only simplification we can really do is cancel those 2's. And so the final answer is going to be 2 to the x ln 2 square root x squared minus 5 plus x times 2 to the x over square root x squared minus 5. For 1c, we want to differentiate the function f of x equals 5 tan x minus 6 log base 10 of x. So we've got a bunch of constants in front, those are just going to stay, and the subtraction, we're just going to use the difference rule, the two parts are going to stay. So the 5 is going to stay, the derivative of tan x is going to be secant squared x, the 6 is going to stay, and the derivative of log 10x is 1 over x times ln 10. Really can't get much simpler than that. That's the final answer. For 1d here, we want to differentiate this function here, y equals x plus 1 to the x minus 1. Note here there's both an x in the base as well as an x in the exponent. If we ever have a situation like that, we need to apply the method of logarithmic differentiation. So I'm going to start by taking the logarithm of both sides. Then I'm going to use my laws of logarithm. This power can come out front. So I'm going to have x minus 1 times the logarithm of x plus 1. On the other side I have ln y. Now I can differentiate. The derivative of ln y is 1 over y times y prime. Here I'm going to use the product rule. The derivative of x minus 1 is 1. Multiply that by ln of x plus 1. The derivative of ln of x plus 1 is 1 over x plus 1 times the derivative of x plus 1, which is 1. To multiply that whole thing by x minus 1. So I get on this side ln of x plus 1 plus x minus 1 over x plus 1. Now we need to solve this thing for y prime. So I'm going to multiply both sides by y. So y prime is going to be y times this whole thing, ln of x plus 1 plus x minus 1 over x plus 1. And y is this thing here. So it's x plus 1 to the x minus 1 times ln of x plus 1 plus x minus 1 over x plus 1. This is the final answer. For question 1e, we have the function g of s equals arc sine e to the s cubed. Here we have actually a composition of three separate functions. So we're going to have to use the chain rule twice here. The first thing we're going to do is we're going to say u equals e to the s cubed. That means g of s is going to be arc sine of u. Now, e to the s cubed itself is still a composition of functions. So I'm going to say here that v is s cubed, which means v prime is 3s squared. And so the u I'm thinking of as e to the v. Well, if I want to take the derivative of e to the v, it's going to be e to the v times v prime, which is going to be e to the s cubed times 3s squared. So now I know what u prime is. So if I want to find g prime, or find the derivative of the original function, I'm going to take the derivative of this with respect to u, which is 1 over the square root of 1 minus u squared, and then multiply by u prime. So I'm going to get 1 over the square root of 1 minus e to the s cubed squared times e to the s cubed times 3s squared. There we go. That there is the final answer. For the last part of question 1, we've got 1f. f of t equals t to the fourth times e to the t times cos h of t. Here we have a product of three separate functions. We have a product of three separate functions. We're going to have to use the product rule twice. First, I'm going to split this up as t to the fourth times this whole thing. So the derivative will be the derivative of t to the fourth times this whole thing, e to the t cosine h of t, is the hyperbolic cosine, plus t to the fourth times the derivative of this guy, e to the t cos h of t prime. Now if I take the derivative of t to the fourth, that's just 4t cubed. It's going to be e to the t times cosine h of t plus t to the fourth times, now if I take the derivative of this, I'm going to have e to the t prime times cosine h of t plus cosine h of t prime times e to the t. Now I just need to do those derivatives. The derivative of e to the t is just e to the t. If I take the derivative of the hyperbolic cosine, the derivative of the hyperbolic cosine is the hyperbolic sine. Notice if it was the regular cosine, it would be actually negative sine. But here it's hyperbolic, so there's no negative sign. It's just sine h of t times e to the t. And there we go. This is fine as the final answer. For question 2, we have a situation where we have an acceleration function given to us, a of t equals t plus 2, and we're trying to find the particle's velocity function. Things we mentioned is that the acceleration is the derivative of velocity, so if we want to go from acceleration to velocity, we're going to need to take an antiderivative. So if a of t equals t plus 2, we want to find the antiderivative of that to find the velocity. The antiderivative of t is 1/2 t squared. The antiderivative of 2 is 2t. And whenever we have an antiderivative, we always have to add a plus c on the end. Then we need to figure out what is this c. Well, we're given a piece of information, that v of 0 is 5. So let's plug in 0 for t and see what we get. We get 1/2 times 0 squared plus 2 times 0 plus c, which just gives you c. But we know that v of 0 is 5. So that means that c equals 5, which means that the velocity function is 1/2 t squared plus 2t plus 5. For question 3, We're given the revenue as a function of the number of items sold. R of x equals 200x minus 0.1x squared. And the cost as a function of the number of items sold is given by this function. C of x is 150x plus 3000. Then it asks us to find the marginal profit function. The first thing to remember when doing this is before we can find the marginal profit, we need to find the profit. And the profit is always the revenue minus the cost. The revenue function is 200x minus 0.1x squared. We're going to subtract the cost function, which is 150x plus 3000. 200x minus 150x gives me 50x minus 0.1x squared is going to stay the same, and then we're going to subtract 3000. Now this is the profit function. If we want to find the marginal profit, that means we're going to need to take the derivative of the profit. When we do that, we get 50 as the derivative of this. We get 0.2x as the derivative of 0.1x squared. The derivative of 3000 is 0. So this here, 50 minus 0.2x, is the marginal profit function. For question 4, we want to find an equation of the tangent line to the function y equals sine cubed of x at the point pi over 4, comma, square root of 2 over 4. The first thing we need to do to find the equation of the tangent line is to find the slope of the tangent line. The slope of the tangent line is given by the derivative. Note before we take the derivative that sine cubed of x is just really another way of writing sine of x cubed. So we take the derivative, we're going to use the chain rule. We're going to get 3 times sine of x squared all times the derivative of sine of x, which gives you 3 sine squared x times cos x. Next, if we want to find the slope of the tangent line, we need to take the x-coordinate of that point and plug it in. The slope of the tangent line is going to be 3 sine of pi over 4 squared times cosine of pi over 4. Sine of pi over 4 is square root 2 over 2. Cosine pi over 4 is also square root 2 over 2. Square root 2 over 2 squared is 1/2. 3 times 1/2 is 3 over 2. That times square root of 2 over 2 is 3 square root 2 over 4. This is the slope of the tangent line. Now to find the equation of the tangent line using the slope, we're going to use what's called the point-slope form. Y minus y0 equals m times x minus x0. This is my y0, this is my x0. So I'm going to get y minus square root 2 over 4 equals 3 square root 2 over 4 times x minus pi over 4. I never said to simplify the equation of the tangent line, so we can leave our answer like this. For question 5 here, we have an equation here for an implicit curve, and we want to use the method of implicit differentiation to find a formula for y prime in terms of x and y. So we need to differentiate this equation implicitly. So first we need to do 2xy. Here we're going to use the product rule. So we're going to take the derivative of 2x times y plus the derivative of y times 2x. Then when I take the derivative of e to the y, I'm going to use the chain rule. I'm going to have e to the y, but then you have to multiply by the derivative of y, by y prime. Take the derivative of x squared is just 2x. Here I'm going to use the chain rule again. I'm going to have 1/2 times y plus 1 to the negative 1/2. And I'll have to multiply that whole thing by the derivative of y plus 1. So let's simplify this. The derivative of 2x is just 2. So I have 2y plus 2xy prime plus e to the y prime equals 2x plus 1 over 2 square root y plus 1. The derivative of y plus 1 is just y prime, because the derivative of 1 is 0. Now, I'm going to move all the terms of the y prime over to the left, all the terms without to the right. So I'll have 2xy prime plus e to the y prime minus 1 over 2 square root y plus 1 y prime. The other side, I'll have 2x minus 2y. I factor a y prime out of here. I've got 2x plus e to the y minus 1 over 2 square root y plus 1. And this whole thing equals 2x minus 2y. Then I've got to divide both sides by this guy. So we get y prime equals 2x minus 2y over 2x plus e to the y minus 1 over 2 square root y plus 1. This is the final answer. For question 6, we have a situation where we have a function h of t, which gives the air temperature h as a function of t, which is the number of hours after midnight. So the first question is, what is the meaning of the derivative h prime of t? Well, h of t is a quantity which is changing. The air temperature is changing. So the derivative h prime of t is always going to be the instantaneous rate of change. Now, what is it the instantaneous rate of change of? It's the instantaneous rate of change of air temperature. What is it with respect to? It's the instantaneous rate of change of air temperature with respect to time. Okay. The other question asks, what are its units? Well, the units of a rate of change are always the units of the quantity that is changing divided by the units of time. So the units here are going to be degrees Celsius per hour, because the units of h are degrees Celsius, the units of t are in hours. Part B asks us, would we expect h prime of 18 to be positive or negative? Again, the hint they give is that t equals 18. 18 hours after midnight is 6 p.m. Well, at 6 p.m., it's getting colder, right? The temperature is falling. That means that the rate of change is going to be negative. So h prime of 18 will be negative. Now, if we talk about h prime of 8, 8 hours after midnight is 8 a.m. Do we expect it to be positive or negative? Well, at 8 a.m., things are warming up usually. Usually at 8 a.m., it's getting warmer. That means that h prime of 8 will be positive. Question 7 asks us to find the equation of the tangent line to the curve y over x plus yx equals 2 at the point 1, 1. Again, to find the equation of a tangent line, the first step is to find the derivative, because the derivative will give you the slope of the tangent line. So take the derivative. First, you've got to take the derivative of y over x. To do that, we're going to take the derivative of the top times the bottom minus the derivative of the bottom. Derivative of x is just 1 times the top all over the bottom squared. For the second one here, we're going to use the product rule. The derivative of the first times the second plus the derivative of the second. Derivative of x is 1 times the first. The derivative of 2 gives you 0. Now we've got to solve this thing for y prime. To do that, I'm first going to clear this denominator. I'm going to multiply both sides by x squared. When I multiply this side by x squared, this x squared will cancel this, so I'll have y prime x minus y. X squared times y prime x is x cubed y prime. X squared times y is just x squared y. And we still have 0 over on this side. Now I want to keep all the terms of the y prime on the left, move everything else to the right. So on the right, I'm going to have a y minus x squared y. Now here, I'm going to factor out the y prime I've got. I'm going to be left with x minus plus x cubed. Now I've got to divide both sides by the x plus x cubed. So y prime is y minus x squared y over x plus x cubed. So here's the formula for the derivative. Now if I want to find the slope of the tangent line, I'm going to take the derivative at this point, 1, 1. So I'm going to plug in 1 for x and 1 for y. So I'm going to have 1 minus 1 squared times 1 all over 1 plus 1 cubed. Well, 1 squared times 1 is 1 times 1, which is 1. 1 minus 1 is 0 on the top. 1 plus 1 cubed is 1 plus 1, which is 2 on the bottom. 0 divided by 2 is 0. So the slope of this tangent line is 0. So using that slope, we can use the point slope form to find the equation of the tangent line. My y0 here is 1. My slope is 0. My x0 is 1. 0 times x minus 1 is just 0. So I get y minus 1 is 0, or y equals 1. Y equals 1 is the equation of the tangent line to this curve at the point 1, 1. For the last question, question 8, we have a table of values. This table of values gives you the values of f of x, g of x, f prime of x, and g prime of x. We want to find a bunch of different things. In part A, we've got the function a of x equals f of x times g of x. We want to find a prime of 1. So first we take the derivative, a prime of x. We can do that with the product rule. We get f prime of x times g of x plus g prime of x times f of x. Plug in 1 for x, we get a prime of 1 is f prime of 1 times g of 1 plus g prime of 1 times f of 1. F prime of 1 is 1. G of 1 is negative 2. G prime of 1 is negative 1. F of 1 is 0. 1 times negative 2 is negative 2. Negative 1 times 0 is 0. Negative 2 plus 0 is negative 2. There we go. We found a prime of 1. In part B, we've got the function b of x equals g of x over f of x. We want to find b prime of 2. So the first thing is you've got to do is take the derivative of b prime of x. B prime of x, we're going to use the quotient rule. We'll get g prime of x times f of x minus f prime of x times g of x all over f of x squared. Plug in 2 for x, we get b prime of 2 equals g prime of 2 times f of 2 minus f prime of 2 times g of 2 all over f of 2 squared. Plugging in the values you've got, g prime of 2 is 0, f of 2 is 3, f prime of 2 is 3, g of 2 is negative 3, all over f of 2, which is 3 squared. We evaluate this. 0 times 3 is 0. Negative 3 times negative 3 is 9. 3 squared on the bottom gives you 9. 9 over 9 is 1. That means b prime of 2 is 1. For part C, we've got the function c of x equals f of g of x, and we want to find c prime of negative 1. Here, when we take the derivative, we're going to have to use the chain rule. So we do the derivative of the outside function, we apply it to the inside function, we're going to multiply by the derivative of the inside function. Plug in negative 1 for x, we get that c prime of negative 1 is f prime of g of negative 1 times g prime of negative 1. G of negative 1 is 1, so this gives you f prime of 1. G prime of negative 1 is also 1. You're going to multiply that whole thing by 1. Now what is f prime of 1? F prime of 1 is 1. So this is 1 times 1, which gives you 1.